Good evening. I've been blessed with the presence of a longtime friend of mine, Barrett Henderson. Barrett is an awesome dude. He has a passion for science, and he strives to become an astrophysicist. Also, he's in high school, so just take everything we say with a grain of salt. Enjoy. Hey, Barrett, welcome to the podcast.
Hey, how's it going?
Going good?
That's good.
So what's your plan for school?
Gonna go into mechanical engineering probably, and then I'm gonna major in mechanical engineering and minor in aerospace. And I don't know, we'll see what happens. Maybe I'll go into something else, but I think that's interesting, so.
Do you want to work for NASA or something?
I mean, that's like the dream, honestly.
Yeah.
Like, if I could, I don't think I'm smart enough. But if I could, that would be like, I know it's like really hard to get into. Like, if you know someone in NASA, it's like a lot easier. But yeah, so I don't even know if it's like possible. But I would try.
I've heard so many stories of like NASA workers. They're like whatever out on the street, and then they're like talking to someone, and they're like, you know what, you're actually really good for the job. Like, why don't you come in?
Oh, really?
On Sunday or something.
That's interesting.
Yeah, like
That's cool.
That just happens.
Huh.
People just get hired for NASA.
Maybe I should just go walk around NASA headquarters.
Yeah.
Hopefully, I don't think I'm weird.
Yeah.
Just camp out there.
Yeah, exactly.
Yeah.
So do you know what school you want to go to?
I was thinking like UVic or U of A, but I don't know yet. I know both of them are decent schools, so yeah.
You're not gonna go to like MIT or anything?
I mean, I don't know if I'll try.
Yeah.
I'll
just
do the
apply.
best I can in school. So I don't know. We'll see how my grades are, but
yeah,
I'm gonna be studying a lot.
Yeah, that's one thing that sucks about wanting to go to like prestigious schools is like you really have to have good grades.
Yeah, you basically
Like-
just have to have no life for like a year.
Yeah, literally.
So
Like even if you're really passionate about the thing,
yeah,
like
Yeah.
just because you're bad at like math will just like completely wreck all your chances.
exactly. Yeah.
So after school, what do you want to like be, Like what do you want to do?
Honestly, not entirely sure. Like I said, aerospace engineer would be cool. Or maybe like a fighter pilot would be
Oh,
cool.
yeah.
Or like a scuba diver, professional. I don't know like how many jobs there are for that, but
Yeah.
yeah. Like I was looking into like underwater welding because I thought that was sick.
Oh yeah.
I don't know, but also it's just like you probably wouldn't live that long, so I don't know if I want to do that. But I don't know. I'm scared of deep water as well, so I don't even know
Oh.
why I want to do that.
Yeah, I don't.
But I don't know. Things that scare me are just they're more interesting. I don't know.
Fair enough.
Like something
So
about
like
it.
you're gonna be an astronaut or like
I would be an astronaut if I had the chance. And that's another thing like that scares me is just space in general. But
well, yeah, it's
Yeah.
terrifying.
yeah, so I don't know.
I think what you should do is get your pilot's license. Because when you like in order to be an astronaut, you have to have your pilot's license and stuff like that.
Yeah.
So you should just do that, and then also
Yeah.
you can fly planes.
Yeah, I was thinking like maybe I could. I think you have to be like a captain in like the Air Force for a while before. I don't know what the requirements are exactly to become an astronaut, but
Yeah, I thought it was like a certain amount of hours in the air.
yeah, I think a certain amount of hours in the air as a captain. I think, but I'm not. I could be wrong.
Yeah, probably something like that.
Yeah.
All right, so let's get into space because that's what you like.
All right.
So everyone knows that we can't travel the speed of light,
Yeah.
right? So how like why not?
Anything that travels like the speed of light has no mass. So I think if we wanted to travel the speed of light, we'd have to have no mass I mean, to be fair, I don't know exactly why we can't travel the speed of light.
Yeah.
But we can get close, hypothetically,
Right.
but we can never actually reach it. And as we approach the speed of light, time slows down, which is interesting. And I mean, hypothetically, if you traveled faster than light, you'd go back in time, which has its own problems as well.
Oh no.
And I could draw like another like thing with that, but because if we traveled faster than light, it would cause like paradoxes. So
Oh yeah. Because like you're traveling this way at the speed of light, but then if time's going backwards,
yeah.
then you're going backwards
Well,
at the speed of light. But
from your
but then you're going
perspective,
forward, and
from
then-
your perspective, you'd be experiencing like normal time, but to everyone else, you'd be going backwards in time. So I don't know if you'd get younger, but I don't know. It's it's weird, man.
That's just mind-boggling completely. So how does like star formation work? Like, what does that even?
So basically, it starts out as like a cloud of hydrogen, and that cloud of hydrogen slowly contracts due to gravity, obviously.
Right.
And as it contracts, it gets hotter and hotter, and the particles get faster and faster. And eventually, the hydrogen starts to collide, and it bounces off of each other. And as it keeps bouncing off of each other, it gets hotter and hotter. And then eventually, they smash into each other so hot and fast that it forms helium. And then that creates an outward force, which is opposing the inward force of gravity contracting. And when those forces like equalize, once they get to like an equal, I don't know how to explain it. Once they reach an equilibrium, the star becomes stable.
Okay.
And then yeah, obviously the star would stop contracting, and then it would just be stable there.
And like all the access stuff is what like forms planets and stuff, right?
Yeah, and the reason why like the rocky planets are like the first like bit, and then the gas planets are farther out, is because all of like the heavier elements weren't able to travel as far because it takes more energy to
interesting.
move them. So that's interesting. So that's why the gas planets are farther out, because it's easier to move those light materials out. So I think that's interesting. And then when a star like starts running out of energy, obviously the nuclear fusion like starts dying down, and once and the star starts contracting again.
So why does that happen?
So once it starts running out of fuel, how the forces were equalized,
Yeah.
they won't be equalized anymore, I guess. So it starts
Oh, yeah.
contracting.
Okay.
And there's this thing called the Pauli exclusion principle, which basically says that like when particles are like really close together, they will like bounce off of each other and stuff, and it'll create an outward force again.
Right.
So once the star crushes down to a certain limit again, it'll equalize again, and it'll create like a smaller star, like a white dwarf, which probably will happen to our star.
That's interesting.
Yep. Yeah. And then so that's happening at like the atomic level, like, and then if we go farther down, if it happened even more like drastically, it would reach a limit where it's not the like atoms crashing into each other, it's like the actual like neutrons inside of like the atom like smashing into each other. And once that happens, it forms a neutron star. So, they're only like 10 miles across, which is really like, that's tiny, but they're extremely dense, like
Okay.
unimaginably dense. And yeah, so that happens when there's just like a ton of matter. And hypothetically, if you added enough matter into it, it would collapse again because the gravity would become stronger than the force of the, I don't know what you call it. I think it's called like, I don't know. I had the name this morning. It's something. It's named after a guy.
All good. All good.
So if you hypothetically added like enough matter, back into the neutron star, it would collapse again to form a black hole, which is interesting. And a black hole is basically just a point of infinite density surrounded by a event horizon, which is
Right.
just the point where light can no longer escape. And so that's interesting.
Yeah. So I saw this thing on black holes where like if the black hole is big enough, you can like go through the middle and like not be affected.
Not notice. Yeah, so the smaller the black hole, if you're falling into it, you'll actually die faster, because you're gonna be a lot closer to the actual singularity, and you're gonna be feeling the gravity a lot more, and you're gonna be
This is
stretched.
like mathematically, obviously.
Yeah.
We don't actually know.
We don't
but
know. We don't know like 100%.
This isn't tested, but
It's not
yeah.
tested. It's yeah. Um. But yeah, you'd stretch out, and then as soon as, from someone else's perspective, as soon as you reach the event horizon, you just like stop in place forever, and you just, I don't know, it's weird. If you're
Huh.
sending a single signal out to like a spaceship that was outside of the event horizon, the the um the signal would just like get more and more redshifted until you reach the event horizon, and they would be reaching, their signal would be like, they'd be getting a signal like every minute. If you're sending a signal out, let's say you're sending a signal out like every second. As you get closer and closer to the event horizon, your signal would, the time between the signals would get farther and farther apart.
Yeah.
And then as soon as you reach the event horizon, they would stop completely, because obviously light can't escape. And then
Right.
it would get more, and the signal would also get more and more redshifted. So, and also apparently they would be able to see the image of you like on the event horizon just before you went in for like I don't know how long, but
Huh.
and then
That's
for
weird.
a massive black hole like at the center of a galaxy, you could be orbiting it for like, well, not orbiting, you could be falling into it for a long time, and hypothetically wouldn't even notice that you passed through the event horizon. And you could still see out, but no one could see in, obviously,
Right.
which is interesting. And I heard
Yeah.
that like if you're inside of the event horizon, you could see time going backwards from outside, and you'd see like the end of time itself as you get closer. But I don't know. That's
Huh.
very hypothetical. So I don't know. It's weird.
So have you seen I forget the movie. What's it called?
Interstellar?
Interstellar, yeah.
Yeah, I have seen it. Yeah.
Yeah. Is it accurate with the like wormholes and stuff like that?
I don't know. We don't know if wormholes are possible yet, because all of like the ideas we have of them, they're like extremely unstable. So if there is a wormhole inside of a black hole, hypothetically, it would be really unstable, with our current understanding. But maybe it's possible. And if there is wormholes, then I guess then black holes wouldn't destroy information anymore, because I guess it would just go through the wormhole and then out like a white hole, I guess. I don't know.
Oh, that's weird.
I don't know. It's weird. Yeah, I don't know.
Well, so have you seen those? There's like a specific black hole that like shoots out like toxic gases or whatever.
Oh,
Have
yeah.
you seen those?
Yeah,
Can you explain that?
No. I was actually just learning about that as well, but like I have to go back and reread all of that because it's like so confusing. But
Yeah.
I don't know. And like black holes, they can have spin as well, but eventually they'll slow down and stop. And when they're spinning, they'll be like warped. They'll bulge out, which is interesting, like towards the equator, just like the Earth, which is cool. But eventually they stop for some reason. Not sure why, but yeah.
So ever since I was a kid, I always thought, like that the universe is gonna end to black holes because I have this question. Okay.
Yeah.
How do black holes do they disappear like stars do? Well, stars go into black holes, but then do black holes like
So, I mean, hypothetically, yes, maybe not the same way the stars do, though. So there's this thing called Hawking radiation, which you might know.
Yeah.
Not entirely sure how it works. like I've read like a decent amount about it. Obviously not enough because I don't fully understand it.
Yeah.
But I don't know. I'm also not sure if like the Hawking radiation that escapes the black hole is, you know, like um if it destroys the information that was in the black hole, or if it gets out the information, the right information that was in the black hole. I'm not really sure, but basically my understanding of it, which is like really basic, is that every now and then the universe will just like create like a particle, like antimatter and a matter pair, and usually they annihilate themselves instantaneously or almost instantaneously. But in this case, the antimatter particle would travel to the black hole while the matter one would escape, which solves the issue that it's just creating energy out of nothing, because it would be destroying obviously some other matter that's inside of the black hole, and then that matter would escape. So I don't know. That's interesting. And that happens because like wavelengths around the black hole or whatever are like canceled out just because of the way black holes work. Not really entirely sure how that works. I watched a video on it, but the guy that was talking about it didn't even seem to understand it fully. So, like, I can't say for sure how it works, but I have to do more research on like, what's it called? Like, I don't even know what it's called anymore. Some weird branch of physics, but yeah.
Yeah. So, yeah, because I always had the thought of like, well, like stars are all gonna eventually become black holes, and then then what? Then it's just gonna.
Yeah, and then eventually all the black holes are going to disappear, and then the universe is going to be like dead after that,
Yeah.
because obviously there's going to be energy, but it's all going to be like useless, which we could talk about later. It's called entropy or whatever, but yeah.
So you talked a little bit about like antimatter.
Yeah.
What even is that?
I don't know, honestly, but at the beginning of the universe, like there should have been mathematically an equal amount of matter and antimatter created, which would mean it would all just annihilate itself and we wouldn't be here. But for some reason, for every like, I think it was like 1,000,000 antimatter, there was 1,000,001 matter. Like, I don't know exactly why, but so most of it got annihilated, but I guess here we are. So for some reason, like beyond all, physics that we know, where like more matter was created. So, but I don't know exactly what antimatter is. It's just like it just, I don't know. It annihilates and then it just creates a bunch of energy, and I don't know.
Yeah, because I never like heard of antimatter until you started talking about it. Like,
Yeah,
however long ago it was. I was like, what?
yeah, it's weird, man.
Because
And
also I can't find it anywhere like online. Like it just doesn't make sense.
yeah,
And you obviously can't explain it, so.
yeah, exactly. Well, I feel like no one can fully explain it though. That's the thing. Like, no one really understands quantum physics fully. There's like you can't find a single person that fully understands quantum physics. So I don't
Yeah,
know.
that's true. Speaking of quantum physics, have you heard of like the theory that there could be like, 1,000,000 different like multiverses or whatever, like different dimensions.
Yeah, I have.
And there's like 11 different dimensions theoretically or something like that.
Oh, are you talking about like string theory?
Yeah.
Oh, so when they say there are 11 different dimensions, I think they're talking about like spatial dimensions or whatever, which are like tiny little pocket dimensions which we can't see or feel, but
Right, it's like technically, you keep going down like into like the microscopic area, like as you keep on going smaller and smaller, and eventually
there's more spatial
there's
dimensions.
more, yeah.
Yeah. So yeah, those aren't different universes, but I don't know. We also haven't confirmed that yet. It's just a theory,
Right.
It's called string theory, I think is what you're talking about. And basically the main point of string theory is to unify like all four forces. And we've unified the first three. We've unified the weak force, the strong force, and electromagnetism, but we haven't unified gravity yet, which is basically the
Right.
entire point of string theory, is to try and unify gravity. We haven't figured that out yet, so
I mean, that's the same thing about Interstellar.
yeah.
They're trying to unify gravity,
Oh yeah, yeah.
right? I mean, spoilers. But yeah, like that's the whole thing is it's all about gravity.
Yeah, I haven't watched that movie in a while, but yeah. So the way Einstein describes gravity is not a force, and basically what a force is like an interaction between like particles, I guess, like not phantom particles. I don't know what you would call it. But whatever. So the way Einstein describes it is like space-time, like matter warps space-time, whereas electromagnetism or like the strong force, for example, the particles interact by exchanging particles in between them, which aren't mass particles, but we know they're real particles because we can detect them as like as photons and stuff. So we know they're there, but yeah. So we're trying to like discover a thing called a graviton, which would, explain like it'd be the particle that's responsible for gravity, but obviously the way Einstein describes it is not as a force. It's just space-time warping, so we don't know yet if it's a force, really, the way the other forces are forces.
Yeah. I feel like gravity is so like funny, how we don't understand it because like in principle it seems so simple.
Yeah.
Like it's like, mass, you know, gravity, physics.
Yeah, exactly.
Like, when we're just doing our day-to-day stuff, like it just like, gravity, it makes sense,
Yeah.
right? Like it's just pulling us to the ground.
Yeah.
But then like when you think about it in the big picture, it's so much more complicated.
Yeah. And what I find interesting is like how Isaac Newton discovered that the stuff that makes us like fall is the same thing that like makes the planet's orbit.
Yeah.
Which is like, how did he figure that out? Like,
Yeah,
you think
literally.
about it, it seems like intuitive to us now, but like back then, that's like, if someone told you that, you'd think they were crazy back then.
Yeah.
So, yeah, it's interesting because he like imagined like shooting a cannonball, and as you shoot it, it would travel around like the curvature of the Earth, and hypothetically, if you shot it fast enough, it would keep falling around the Earth, which. So that's how he discovered orbits, and then he was like, "Huh, that's probably what the planets are doing around the sun." So yeah.
Yeah, I get that makes a lot of sense.
Yeah.
That's pretty smart.
Yeah, it is like he's a genius. Like,
Yeah, literally.
he's probably one of the most important physicists of all time, actually. So yeah.
Yeah, it's interesting.
Yeah, and also gravity. Another fact about gravity is it travels at the speed of light, which you might have known. So if the sun suddenly disappeared, we wouldn't notice for 8 minutes.
Yeah.
And also gravity, it's like, sorry, it's an exchange of information. So it actually takes energy. Gravity like takes energy out of the objects that emit gravity. So or whatever. So the Earth actually like the amount of energy produced by Earth's gravity is like enough to power like a small heater. But it's like so minimal. And so what that means is the Earth is very slowly slowing down because of the loss of energy from that. So eventually the Earth, if the sun never like exploded, the Earth would eventually fall into the sun, but that would take God knows how long.
Yeah, exactly.
Like, yeah, it's like very minuscule, the actual amount that it's falling, but it is, so yeah.
So you talked a bit about the four forces.
Yeah.
Do you want to explain the other three?
Yeah, so basically electromagnetism is what's responsible for, keeping electrons orbiting around the nucleus.
Okay.
And I don't know like electromagnetism fully. I need to like learn more about magnetism stuff and like magnetic fields. It's really interesting.
Right.
And then the weak force is responsible for nuclear decay, which, like, I guess I don't really know which particles decay into other particles, but um, yeah. So, like, a high energy particle eventually would decay into like a lower energy particle and become something different. It's weird. And then the strong force is responsible for keeping gluons together, and gluons make up neutrons and protons, not electrons. Those are like their own things. And so another interesting thing about like gluons is if you tried to like, I think I told you about this one time, but if you tried to pull a gluon off of like its other two pair, because gluons come in pairs of 3,
Right.
and there's different types of gluons, but I'm not really gonna get into that. But if you tried to pull it apart, you'd have to put in so much energy, because the farther apart you pull them, the stronger the force between them becomes, which is like completely opposite to gravity. And it's
Right.
really interesting, and I don't really know how that works. But eventually, if you put enough energy in, it'll just create new gluons with the energy that you're using to pull them apart. So you can never get a gluon by itself. Like, it's like pretty much impossible.
Huh.
So, which I think is cool. But
That's so weird.
I know I don't know. I don't even know where I learned that. I might have read it somewhere, but I think it was like, I think I read it in like a book by Neil deGrasse Tyson or something. But yeah,
Yeah, fair enough. So that's the weak force.
yeah, or that's the strong force.
That's the strong force.
Is the force that pulls
Oh, okay.
gluons together, and then the weak force is responsible for nuclear decay or whatever.
Right.
And then another interesting thing is like all like electromagnetism, for example, is the strongest, one of the strongest of the forces. Like gravity is the weakest force. It doesn't seem like that, but it's only because the other 3 forces are extremely short range. So down to like the subatomic level, like gravity's almost like you can barely notice it. So, and the only reason like we can feel gravity is because it adds up and it can travel a super long distance. So that's why we can feel it from the sun and whatever. But like, I guess if electromagnetism didn't like cancel itself out, because obviously there's the negative and the positive particles which cancel it out. So the Earth, with all of its what do you call it? Like all of the electromagnetism together, I guess, just like all the particles cancel each other out on average, so we don't feel it at all.
Right.
Which is interesting. But yeah.
Um. So I have a question.
Yeah.
If you had the chance, like if Elon Musk called you up,
Yeah.
would you go to Mars?
Yes. Like any day of the week, probably, honestly. Like it's just something that like no one else would get to do, basically. So I don't know.
Yeah, because there is going to be a high chance of death.
Yeah. Yeah, exactly.
And like people were thinking like that it's going to be like this, amazing thing or whatever. It's going to be so nice. But like obviously it's not going to be that nice, and there's obviously going to be a lot of work.
Yeah.
But yeah, like me as well, I would also say yes.
Yeah.
Because yeah, like that's an opportunity that like you just can't pass up.
You can't pass that up.
Like
Yeah.
I don't care how much work I'm going to have to put in, like whatever, I'm going to Mars. Like
Yeah, exactly.
who cares?
Yeah. It's like being in Star Wars. I don't know.
Yeah, exactly.
Like that's so cool. And you'd also be remembered for like forever, basically, because you'd be in the
exactly.
history books and whatever. So, yeah.
Yeah, all you have to do from there is just like do something cool on Mars, and there you go.
Yeah. Yeah, exactly.
Put the flag down. Easy.
And you could say like, "Oh, I'm the best basketball player on the planet."
I feel like a lot of that stuff is gonna happen like after the first colony is like actually set up and everything. Like everyone's just gonna start doing stuff like that.
Yeah.
Easy Guinness Book of World Record stuff. Like
Yeah. Yeah, the first like colony, it would be super rough, but like I mean, probably after they expanded a bit, it'd become easier, but Yeah. And I remember Elon Musk saying he wants like bars on Mars, so he'd call it a Mars bar or whatever. I don't know, I thought that was funny. And apparently we'd create like an atmosphere around Mars by like nuking the poles or whatever,
Yeah,
which yeah,
that's a weird one.
it is a weird one.
I feel like we might not do that.
Yeah.
Because it's really dangerous. Like,
Yeah. I mean, Mars can't get too much worse, to be
well,
fair.
yeah, that's true. But like, I mean, I haven't done the research on this, but like, I feel like there's a lot of like bad things that could happen if we did that.
Yeah.
Like, because it's the only really habitable planet in
Yeah.
our solar system.
And it's not even habitable.
Yeah,
At all.
yeah, exactly. But like if we nuke it, it might become like way worse.
Yeah.
Like it might become like, like toxic and stuff like that.
Yeah, exactly. Yeah, I'm not sure how that would work exactly. I know that like the core of the planet's like inactive basically, but so there's no like magnetic field, I guess. I don't, or maybe there's just a really weak magnetic field. I'm not really sure.
Oh, yeah.
It's one of the two. But yeah, so it doesn't there's not much protection from like incoming asteroids and stuff like that.
Oh, yeah.
Yeah. So also makes it really dangerous.
That's really interesting, like the magnetic field. Like that's what the what's it called? The lights in the sky.
Oh, like the Northern Lights.
Yeah, Northern
Aurora
Lights.
Borealis.
Yeah, Aurora Borealis, yeah.
Yeah.
So how does that like what does that do like on Earth?
What does what do? The
Like
Aurora
the-
Borealis?
Yeah, like the magnetic field or
Oh,
stuff
well,
like
it
that.
protects us from like solar flares and stuff, which obviously is why we see the Aurora Borealis is like solar flares. And that's like, I guess, the magnetic field protecting us or whatever. And I'm not really sure exactly.
That's so weird.
Like I said, I need to do more research on like magnetism and stuff
Yeah.
because I was doing research on it, but like it's super confusing. Like it sounds like somewhat simple, but it's like it's very complicated. Like once you get like deep into it, so yeah.
Yeah, I really want to have Mr. Whalen on so he can, because I feel like he's done a bit of research on
Oh, definitely. Yeah.
electromagnetism and stuff like that.
Yeah.
But yeah, it's so weird.
Yeah. Exactly. I have so many questions about physics, man. It's like there's so much I need to ask. Like I remember I asked Mr. Whalen like what would happen if like two people traveling half the speed of light towards each other would like what would they measure
Right.
each other to be like traveling, what speed? And I don't know if he gave us like a great answer because I remember you were there, but yeah.
Yeah, because isn't it like technically they would say that the other was like
Traveling at the speed of light hypothetically, but obviously that's not possible.
yeah,
You can't measure someone to be traveling the speed of light
right.
because it's not possible. Because that, yeah.
And then like time is a whole weird thing going on there.
Yeah, so obviously both of them would be like experiencing time slower, and I don't know how that would
Well,
affect
yeah,
it. But I mean, yeah, that's probably why it's possible.
because like theoretically, it's totally possible to have two people going
Half the
half
speed
the
of
speed of light.
Yeah,
That's achievable.
yeah,
Yeah, but like I don't know.
I don't
It's
know.
So weird.
It's something I've wondered about for a while. And also another question I've had is like, what gives particles their charge? And like, I still don't know. The best answer I have is like, the gluons that make up like the protons and neutrons are like the certain types of gluons that make them up is basically what gives them their charge, but I don't know why. That's something I don't know, and I don't think there's an answer for that actually. I don't think there's an answer for that yet. So cuz nothing you could say would like anything you would say you just ask but why? So you just ask more
Yeah.
questions.
Yeah, exactly.
So I don't think there's like an actual answer to that one yet, but because I've done like so much research on that, like I've like gone through like so many different articles and stuff, but I can't find an answer. So yeah,
So you've done like so much research and stuff like ever since you were a kid. I feel like you're so interested in like
yeah, it's mostly been in like I feel like the past 5 years mostly. Not yeah,
Why do you think that you like it so much? Like, what draws you in?
Probably like watching like Star Wars as a kid. Star Wars as a kid.
Star Wars.
Star Wars. Hey, don't make fun of me for that, all right? I do it. I do it. They keep making fun of me on the way I pronounce Star Wars because I say Star Wars. I don't
You
know.
said it on the podcast.
I'm sorry. That's just how I say it.
Clip that. Clip it.
Yeah. Star Wars and
Yep.
I don't know, watching I don't know. I think it's mostly Star Wars, honestly. I just thought it was cool as a kid. I used to be like a big Star Wars nerd, but I guess I don't know. I don't know what happened, but
Fair enough. Look at us both with our legs up.
yeah.
All right, on to a different topic.
All right.
Have you been following Neuralink?
Honestly, the last thing I heard about Neuralink, aren't they allowed like human testing now?
Yeah, they just approved human testing.
Yeah, I don't know how that's gonna go. I know it's to help people with like neurological disorders, I think.
Well, at first they're just doing like simple stuff like that. They're trying to, because they can, like completely fix like paralyzed people.
Yeah.
They can fix stuff with like DNA. Like if you have some like medical like imperfection,
Yeah.
they can fix it real easy. Which is just insane. Because they can change like your genetic makeup.
Yeah, that's so weird, man.
Yeah, and it's kind of weird because we kind of know now that in the future, like there is going to be genetic modification,
Yeah.
and it's going to be really easy. Like it's going to be so like affordable, and like everyone's going to be doing it.
Mhm.
Like no one is like allergies are just not going to exist.
I mean, yeah, I hope so. That'd be great.
Yeah, like there's not going to be like any like people like paralyzed or anything
Yeah.
like that. Like this out the window. Um, there's thoughts about like regeneration.
Mm.
Because you could just like I don't know, like put like scan your arm or whatever that or like scan both arms if like one of them is gone or whatever,
Mm.
and then it'll just like remake it.
Dude, that's so weird. That's so. Could we like stop cancer with that?
Oh yeah,
Yeah, that's
yeah. Like all diseases will just like easily be fixed because we can just make up a cure specifically for your like genome and DNA.
yeah. So could you like live forever? I don't know how I'm asking you this because
Um,
you're the host, but
I think it might be possible to live forever in the future. Yeah, just because like you just like regenerate everything.
yeah,
And like yeah, because basically what we could do is just take your DNA and like download, like this is a big one with Neuralink. You could just download everything that you've ever learned onto a computer, like onto a supercomputer, and then kill yourself, right?
yeah,
Like whatever.
Yeah.
They would dispose of your body, right? And then just make a new perfect body at like 22
yeah.
and put all your memories back into it. Bam.
Would it still
There
be
you go.
you though?
Yeah.
But like, would it just be like, would it just think it's you, or would it like actually be you? Would it be like one continuous experience, or would the old
That's a good
self
question.
actually be dead? I don't know.
I don't know either.
I feel like the old self would be dead. I don't know if it matters.
Well, because you would have, yeah, exactly. Because you'd have all the things that you've ever thought about, right? Like it would be the exact same as your old self, but
The
Yeah.
old self's dead, which would kind of suck.
yeah, it's kind of
Yeah.
weird. I feel like 90% of people are just gonna not care that it's not the original you.
I feel like I
'Cause-
would. I don't know.
Really? You would give up eternal life for?
Well, it's because you're not even experiencing it anymore. It's like it's a copy of you experiencing it. I mean,
Yeah,
maybe
but
I'd do it. But
It's like technically you.
it's technically you, but I don't know. You know, because like the copy of you would obviously think it's you, but like I don't know. It wouldn't like if
Well,
it's not a
you'd be
continuous
dead.
if it's not a continuous experience. I don't know if it's
Right.
like
And there's like,
uh,
would you just be duplicating your brain and putting it on a computer, or could you actually transfer like all of that stuff? And it's weird with like the information and stuff like that, um, because like the amount of space that you'd have to have on a computer is like, astronomical,
yeah,
right?
yeah.
Because you're putting like everything from your brain. Um, but yeah, Neuralink, human testing. It's really weird.
Yeah, I don't know. I
I
don't know.
don't. I watched a video about how they're like being able to do human testing, and it's like it didn't make sense.
I've seen something about it, but I haven't looked into it much. I've seen that they did testing on a pig and they showed that, but yeah, I thought it was interesting.
Yeah, and they did a bunch of tests with monkeys.
Oh, really?
And they gave it a bunch of different games to
Mhm.
play, and did it with no problem, just from the brain, no motor movements or anything like that.
Oh,
And
yeah.
yeah, and it worked perfectly.
Yeah, I've seen like a video of someone like playing like Pong just on their with their brain. Like that's
Yeah,
weird. I don't know if it was Neuralink or something else. I don't know, but
yeah, it is really weird. There was also, I don't know if you've heard of this, but there was this thing where you could like put a thing on your back. It was like this like pad thing, or
oh,
it was like a vest kind of thing, and basically, um, you could like use the muscles in your back to like say things.
what? Like,
So here, let me try to explain this. So basically, um, there it would like pulse at different spots in your back because
mm,
there's so many different muscles in your back,
yeah,
and we realized that you can use your brain to like do each little muscle, like like mind muscle connection.
yeah.
Basically you can train that, and so like if you're um like Stephen Hawking, how he
Yeah,
had to like
yeah.
do like stuff like that. Basically, they could just put this vest on, and then they would have a little speaker, and then he would just talk,
Mm.
and it would like just convey everything he was saying, and he would just be able to use it back. I mean, obviously he's paralyzed, so he couldn't do it, but like
How long would it take to like practice that, or is it like
it
very
was
intuitive?
it was like only a few months.
Really?
Yeah, they had these people. They didn't like do a language or anything like that, but they would like be able to play like fully fledged games.
Oh, really?
Yeah,
That's crazy.
like you could play like you know like Star Wars some, and have like all the movements and everything just with your back. Yeah,
That's really weird.
yeah, but what sucks with that is like it's a really cool technology, but now with Neuralink and stuff like that, like just in the near future, we're gonna be able to do the same things.
With her brain.
Yeah, and you're not gonna have to train it
Yeah.
because
Hmm.
it's just in your brain.
Yeah, I think like virtual reality and stuff would be cool with Neuralink if they ever do that.
Yeah,
Like, cause you wouldn't have to like actually be moving, cause you could just like I don't know, like all in your brain or whatever. Do it, play a game. I don't know.
yeah,
I
it's
think
it's gonna be really weird.
yeah,
Um, but what will be nice is, with like the Google goggles thing,
yeah.
you know, what are those
I've
called again?
no clue. I've
Forget.
seen them though.
Um, but like say you had those on, right? And then you're playing a game with your head through the goggles,
Yeah.
and then you can see the road in front of you,
Hmm.
and you're just taking a little jog while you're playing Elder Scrolls,
Yeah,
you know?
that is weird. Hmm. I don't
Yeah.
know.
And the craziest part about that is that's not even like far off.
Yeah, I don't, dude. The future is gonna be crazy. I don't know. We'll see what happens. I mean, we also thought there was gonna be like flying cars by now. I
Yeah.
mean,
In
there's
2015, there was
there's
supposed to be flying cars.
yeah, according to Back to the Future.
Yeah.
um, yeah, I think there actually is a flying car now though. Like it was like They just unveiled it like a few days ago or something.
Oh, really?
Yeah. I don't know. It looks actually like a car as well.
Huh.
So I don't know. It's cool. It's got like little. It's basically just a drone that looks like a car, but
Oh, yeah.
it's still cool.
Yeah.
Yeah.
That's pretty interesting. Yeah, I feel like the future is just gonna like just pop in front of us.
Yeah.
There is this thing though that like the future only applies to rich people.
Yeah.
You know, like with cars and things like cars have gone like such a long way,
Yeah.
but we just don't experience it.
Yeah. They're so expensive now as well.
Yeah. Yeah, so it's like all the billionaires have like these like just insane fancy cars and things like that. And like the regular world just doesn't like we just don't know because it's so like crazy money.
Yeah.
But yeah.
Yeah. I wonder. Maybe it'll get cheaper eventually. I will.
Yeah. Yeah,
See.
exactly.
I'm hoping like space flight gets cheaper. Like
Yeah.
like
Like where they just go into space for like 5 minutes and then they come back down.
yeah. I think it's more like an hour or something like that. I don't really know
Oh, really?
how long it is, but it's not. I think it's longer than 5 minutes, but it's like $250,000 for like a ticket, so or something like that. I don't know.
Would you rather go to space or go to the Titanic?
Space, dude. Honestly, underwater is scarier than space.
It is.
Yeah,
Because underwater there's like pressure. Like we know the pressure in space. And
Yeah.
it's always like pretty constant or whatever. It's always like in a range.
it's like like almost zero.
Oh, really?
Well, there's not really
Well,
many.
it's more like just like asteroids hitting whatever.
Yeah,
But yeah, underwater it's like there's so many random forces.
Yeah.
Like undercurrent and stuff
exactly. And I don't know.
that like we don't even like
And
think
there's
about.
creatures down there. At least space doesn't have like
Space creatures.
yeah.
Yeah.
Yeah. At least you're not gonna get eaten by a space shark. So-
Yeah, exactly.
And also, like, you just can't like underwater. You can't see anything, which just makes it so much scarier as
Yeah.
well.
And the fact that like we haven't explored like 90% of water,
Yeah.
like that's just like that's crazy.
Yeah.
Like there's so many species underwater that were like there was some statistic that like every year we find like 50,000 different species of underwater creatures
No, really?
every year.
That's a lot. It's a lot. Is it like microscopic?
No, like just like regular whatever. Like obviously there's lots of like subspecies.
Yeah.
But
Yeah.
like 50,000 every year?
Yeah, that is pretty crazy.
Like yeah, like there's obviously like so many things that like are definitely in the water that we don't know about.
Yeah. I don't know. Yeah. Like, who knows what could be down there? Like a megalodon. Like you know how many like skeletons? I guess Isaac would
Yeah.
know a lot about this.
I
But,
should have
like,
asked him.
There's probably some like gigantic skeletons under the water or something. But
Yeah. What does suck though, is that so in space, right? All the people that go to space are like, you know, really sophisticated and have done this before. And they've gone to school,
yeah.
they have PhDs,
Yeah.
et cetera, et cetera. The people that are, you know, like basically, it's way easier to make like some bullshit claim about something in the water than it is in space.
Yeah.
Because in space, there's obviously not random aliens and stuff like that. Like we're obviously gonna know about that,
Yeah.
right? But underwater, because there's so many things that we don't know, there's like a bunch of just like crap that people like just say is real,
Yeah.
and like stuff like that.
Like Isaac was talking about how they made up dinosaurs.
yeah,
Yeah.
exactly.
Yeah.
And that like it's so easy to do that kind of a thing.
Yeah.
Especially now with the kind of technology that we have.
Yeah, exactly.
Like it's so easy to fake stuff.
I know. And like I feel like underwater is probably even harder to like explore than space is a lot
Yeah.
of times. I mean, obviously we can't like travel to another star system yet, but like I don't know, getting down like the Titanic was like 13,000 meters deep or whatever. Like,
Yep.
but like the deepest sub, like that goes down is like 2,000 or whatever, or I don't know. Like the deepest, like what do you call it? Like Navy submarine or whatever goes down like 2,000 meters, but
Oh yeah.
because it's just so like the pressure is just like crazy and stuff. But yeah,
Yeah, that's pretty creepy.
it's terrifying.
Yeah.
That's like one of my biggest fears, like underwater and like also heights. So, and also obviously being an astronaut would be cool, and I think I said being a scuba diver would be cool. So,
Yeah.
like my two biggest fears is like what I would want
Yeah.
to do for a job.
I mean, fair enough.
Yeah. Yeah.
So let's deviate from the boring things.
All right.
Do you have any like personal philosophies, like things that you live by?
Damn. I wasn't prepared for that. I don't know. Let me think. There's like a quote. I think it's by like Gerard Way. It says like, one day your life is gonna flash before your eyes, so make it worth watching. That's something like I try to live by, and I don't know. I really like that quote. And like you learned about Immanuel Kant and stuff in philosophy and like the four categorical imperatives, and like how you should always act as like how you want everyone else to act, I guess, in a certain scenario. I don't know how the exact saying goes, but like I try to live by that, but also it's hard sometimes. Like I don't know, because obviously, you know, if let's say you're on a train track, let's say there's a train track going two ways, and there's like five people, or you're like your mom.
Right.
I would obviously want to hit the five people.
Really?
Yeah, but like everyone else would like obviously I would want everyone else to hit their mom, because if it hits five people, that's like five people or one. But
Right.
if it's my mom, then obviously my mom is more important than five people.
Right.
So, like, if I lived by like Immanuel Kant, I would have to hit my mom.
Right.
So like you can't. I don't know. I can't like always live by that. But yeah. So
So you're selfish, is what you're saying.
I am. It's true. But I think
Yeah.
everyone is kind of selfish to a certain extent. So I don't know.
Yeah, and you can say like, "Oh yeah, well, I would obviously hit my mom because my mom's only one person."
Yeah.
But if you're actually in that situation,
Exactly.
like
Yeah.
everything's gonna be like, "Oh no."
It's just gonna be like a quick like half-second decision to like switch the.
Yeah, I wish that they did some like test on people, like
Yeah.
with the trolley problem, and then
Yeah.
they like shock you if you take more than like 2 seconds.
Yeah. Or like make them think it's real. I mean, that'd be kind of like
Yeah.
that'd be really cruel. Like really, really cruel. Like if you just like woke them up and they just happen to be in a train and they're super confused. And they're just they're just barreling at 100 kilometers an hour towards what they think is their mom, and then there's five people like see what they would do. I don't know. And then like test them before that to see what they would actually
Yeah,
do, and then just
exactly.
like wipe their memory.
Yeah.
And then wake them up on a train.
Well, I don't even think it would matter like if they had already gone through the scenario before. Like I don't know if it would actually matter like if they said I would kill the mom, or if I would kill the five people, compared to when they just like when you just put the mind to it, like what it says.
Yeah.
Like it doesn't even matter if you've already looked at the problem before.
Yeah. But also, obviously, you would want to test like what they say, relative to like what they actually do. I guess I don't know,
Yeah.
because like what they say, because what they say could be different. I don't know. That'd be interesting. Yeah.
But yeah, and, I think that's definitely something that we could probably do in the future.
It'd be really cruel though. I don't know if that'd be legal.
Yeah, it'd be like the Hunger Games with the Mockingjays.
Yeah. Yeah. There's a lot of like experiments that like we could do, but they're just like super
Yeah.
super immoral.
Hey there, this is Hudson, just coming here to let you know that this is a two-part episode, and I'd like you to tune in for the next episode right over here. Bye-bye.